on simple classification of substances. I hope you're going to enjoy. Now, we begin by defining classification, which is the grouping of substances according to their physical properties. Substances are either pure or impure. For example, a pure substance is made up of a pure solid, liquid, or a gas. Now, a very good example of a liquid is water. So when we talk about water which is not contaminated, then it is a pure substance. We also have ice as a solid, which is also a pure substance whenever it's not contaminated with anything else. And we also have gases, which are pure. If, like, for example, we prepare oxygen gas in the laboratory, before it is contaminated, it's a pure gas. And so those are examples of pure substances. Now, an impure substance contains two or more substances. For example, if you mix water with common salt, table salt, then it becomes impure. So mix water with milk and freeze it to form a solid. That will be an impure solid. Then also when we talk about air is not pure because it consists of so many substances combined together. In air, we have oxygen, we have nitrogen, we have dust particles, we have water vapor, and so many other things which are present in air. So it is not pure. So in our introduction, we have realized that we can be able to classify substances depending on their physical properties. And in that grouping, we have substances which are pure and others which are not pure. And we have said a pure substance, it's just made up of itself. It can be a pure liquid, solid, or gas. Then impure substances consist of two or more substances combined together. Now, from there we can now move on to mixtures. The word mixtures comes from a combination of several things. And the correct definition for a mixture is a combination of two or more pure substances which can be separated by chemical means. Now, an example, a very good example is maize and beans. Looking at maize and beans, each one of them has retained their physical properties. For example, beans, you can tell the beans from the mixture by looking at their color, their shape. Those are physical properties. Then also you can tell this is maize from that mixture by looking at its color and its shape too. So a combination of two or more pure substances which can be separated by physical means. Now, maize and beans, how can you be able to separate them? Of course, by hand picking. Hand picking, you can pick the beans because you're able to see them because of their shape and color. Or rather, you can pick the maize seeds because you're able to see them. Now, the three states of matter in nature appear mainly as mixtures of one with the other. Now we are saying in nature, when you consider the three states of matter, which are solids, liquids, and gases, mostly they appear combined together. They appear as a mixture. And a very good example of that mixture is air. Air itself. Air is a mixture of so many gases. And apart from the gases, we also have dust particles, which represent solids. We also have water vapor, which represents liquid. So air is a very good example of a situation whereby the three states of matter appear mixed together. Now we have different types of mixtures, and it depends. It depends with the components that are present in the mixture. So at least two components have to be present in a substance for it has to call it a mixture. Now examples of types of mixtures include a solid mixture. Now a solid mixture is a mixture of two solids, and a good example is what we've just talked about, maize and beans. Other examples would include salt and iron filings. We could talk of sulfur, it's a solid, and iron filings. Those are examples of solid mixtures. Then we have another type of mixtures called the liquid solid mixtures. These are mixtures that constitute a liquid and a solid mixed together. And a good example is a mixture of water and sodium chloride, in brackets common salt. That is a very good example of a mixture of a liquid and a solid. Then we move on to liquid mixtures. Now here we are talking about two liquids that are mixed together. A good example would be water and ethanol. Also water and paraffin, and so on and so forth. Then finally we have a gas mixture, and air is a very good example of a gas mixture, because in air we have the nitrogen gas, we have oxygen gas, we have dust particles, we have so many other gases there, including the dust, water vapor, including all those are mixed in air. So air is a very good example of a gas mixture. Now we need to move on to separation of mixtures, how we can be able to separate these mixtures. But before we get to that, we have some basic concepts which we must first take into consideration, or rather understand what they mean. And the first one is a solute. Now we shall come along words such as a solute as we discuss about the separation of different mixtures. And we find that a solute is a substance that dissolves in a liquid. And a very good example of a solute is sugar. So sugar can dissolve in water very well. And therefore, it is an example of a solute, a substance that can dissolve in a liquid. Now, we have a solvent. Now, a solvent refers to that liquid in which a solute dissolves. The liquid in which a solute dissolves is called a solvent. An example of a solvent is water, which we say is the universal solvent. In other words, so many solutes dissolve in water. Then we have another term, crystallization. Now, crystallization is the process by which crystals are formed from a hot saturated solution as it cools. So normally for crystals to form, we normally saturate a solution by evaporating excess water. Then whatever remains in the evaporating dish, we allow it to cool. And in cooling, crystals are formed. So that is crystallization. We shall look at it in depth as we move on. Now, we have another word here, a solution. Now, a solution is the resulting uniform mixture of a solute and a solvent. For example, water is a solvent and salt is a solute, or even sugar is a solute. So the moment they mix together and form an homogeneous solution, then that is a solution. So solutions can either be homogeneous, that is uniform, like a solution of sugar and water, or they may not be uniform. Yeah, but let's just know a solution is a mixture of a solvent and a solute. Yes. Then we have another term here, a filtrate. Now, a filtrate is a liquid that passes through the filter paper during filtration. Now, we shall learn about filtration in details, and you'll realize that it's normally a setup whereby a filter paper is placed inside a filter funnel. Then, whatever is solid from the mixture will remain trapped by the filter paper, and the liquid will pass through into the other container. Therefore, whatever passes through that filter paper during filtration, that is the filtrate. We shall talk about filtration in details. Now, then we have a saturated solution. A saturated solution is a solution in which no more solute can dissolve at a particular temperature. That is a saturated solution. Now we have more terms here. Crystallization. No, we talked about crystallization. That's a repetition. Now we have miscible liquids. Now when we talk about miscible liquids, we are referring to liquids that can mix completely to form one layer. And an example of such liquids are water and ethanol. Those are miscible liquids. When the two of them are mixed, you will not be able to tell the difference. It just forms one layer. Now, we have immiscible liquids, and these are liquids that cannot mix completely, and they form different layers. And a good example is water and paraffin, or water and cooking oil. So those are some of the terms we shall be coming across as we discuss the methods of separating different mixtures. Now, what are some of these methods of separating mixtures? Now, separation of mixtures depends on differences in physical properties of the substances in the mixture. Now, these physical properties would include solubility, the solubility of the substances in that mixture, the density of the substances in that mixture, the boiling points of the substances in that mixture. Those are some of the considerations which now will direct us into choosing the right method of separating given mixtures. Now let's now move on to some of the methods of separating mixtures, and we begin with separation of solid mixtures. Now, solid mixtures can be separated by magnetic separation. Magnetic separation is whereby you use a magnet to separate a solid from another. Now, what makes it possible for us to use a magnet is if one of the solids is a magnetic material. Now, what happens is that you place the magnet on top of the mixture, and the magnet will attract the magnetic material. Like an example of a mixture of sulfur and iron filings. Now, we know iron is magnetic. It will attract, a magnet will attract iron. Therefore, in a mixture of sulfur and iron filings, you just pass a magnet on top of the mixture, and that magnet will attract all the iron filings. They will stick on the magnet, and the sulfur will remain on the container. And by so doing, you will have separated the iron filings from sulfur. Now, this method is applicable because it is used in recycling plants. Now, when we talk about applications, is how is this method applied in our lives, in our daily lives? So, in those places whereby we have the recycling of materials, then magnets are used to separate magnetic metals from other materials which are not magnetic, and also from plastics. Now, this one normally happens in scrap metal dealers. So much is taken to them, a lot of crap. So in order for them to be able to separate the magnetic materials from the non-magnetic materials or plastics or PVC, or those are plastics, and such, rubber and so on, then they use a magnet. So using a magnet, they are able to trap all the magnetic material and leave the rest. Another place where magnetic separation is applicable is during the mining of iron. We know that iron and other metals are mined from the Earth's crust. So in order for us to separate the iron from other materials, remember, you have to dig it from the Earth's crust. It comes out with mud, with rocks, with soil, and so on and so forth. So in order now to get the iron, we use a magnet to attract the iron and then leave the other materials. So the magnetic separation is an important method of separation, and it's applicable in those two cases. Now, another method which we use in separating solid mixtures is sublimation. Now, sublimation is the process by which a solid changes to vapor or a gas by heating. Now, for this method to be applicable, one of the substances in the mixture must be a substance that sublimes. It must be a substance that sublimes. And we have said to sublime is to change from a solid to a gas by heating. Now, a mixture which could be separated using sublimation is a mixture of sodium chloride and iodine. Iodine is a sublimate. It's a substance that changes directly from a solid to a gas by heating. So, this mixture is normally placed in a sealed container which is covered with an evaporating dish with cold water. So what happens is that when you heat the iodine, which normally is some shiny black crystals, shiny gray crystals. So when you heat iodine, it changes immediately to a purple vapor as shown in this diagram. It changes to a purple vapor, and because we have said that we place an evaporating dish on top which has cold water, when that vapor gets into contact with the cold underneath of the evaporating dish, then it solidifies again, and we are able to see our gray particles settling at the bottom, underneath the evaporating dish. So what is happening here is that you heat iodine, it immediately changes to a purple vapor, which then solidifies on the cooler part of the evaporating dish. So after it collects there the dark gray crystals of the solid, then you can be able to scrap it out. Now this method can be used to separate a mixture of sodium chloride and iodine. The fact that iodine sublimes, then when you heat this mixture, the iodine will sublime and the sodium chloride will remain at the bottom of the beaker as a white solid. So to obtain the iodine, you just scrap it from the underneath of the evaporating dish, as we have seen in this diagram. Now we have some other substances that undergo sublimation when heated, and they include anhydrous iron 3 chloride, anhydrous aluminium chloride, benzoic acid, dry ice, which is also called solid carbon 4 oxide. Now, we have said that when this purple vapor reaches the cooler parts, it solidifies to iodine. That process whereby now the vapor is changing to a solid, whereby the vapor is changing to a solid on that cooler part of the evaporating dish, is called deposition. So the opposite of sublimation is deposition. Sublimation is the change from a solid to a gas by heating. Then the process whereby this gas goes back to a solid is what we call deposition. Note that on both sublimation and deposition, we do not pass through the liquid state. Excuse me. So the change is direct from a solid to a liquid, then a solid to a gas, then a gas to a solid. Is this sublimation useful or applicable anywhere in our lives? Yes. We are always eating ice cream, and sometimes even the ice cream vendors carry the ice cream around and it is in the solid state. Have you ever asked yourself why this ice cream is maintained in the solid state, yet we don't have ice, we can't see any water around? Now, that is one of the applications of these substances which sublime, and in particular dry ice. Now, dry ice is used in these cold boxes by ice cream vendors and it is preferred over ordinary ice. Why? Because number one, it sublimes, so it does not leave wetness. Now, if it were ordinary ice, we know very well that ordinary ice melts and turns to a liquid. So you can imagine if they would be walking around with ordinary ice, it would really make them wet. Each time it melts, it is leaving a lot of water and it would be chaotic. Therefore, dry ice is preferred for one reason, that it sublimes, hence it does not leave wetness, because we have not talked about any liquid state in sublimation. So it sublimes without leaving wetness. And the other reason why it is preferred is because it's a better coolant than ordinary ice. It cools better than ordinary ice. Now, let's look at some of the questions from that area we've just covered. And the first question is, state and explain the observations made when iodine crystals are heated in a boiling tube. State and explain the observations made when iodine crystals are heated in a boiling tube. So we've just discussed that the black crystals change directly to purple iodine vapor. Now, some books say black crystals, shiny black. Others say gray. So I think we shall stick with KLB, which says shiny black. Shiny black crystals change directly to iodine vapor. Now, question number 2. Given a mixture of lead 2 oxide, iron 3 chloride, and sodium chloride, describe how this mixture can be separated to obtain a sample of each. Now, when you're faced with such a question, first of all, check whether any of those substances sublime. Like in our case here, we have lead 2 oxide, it does not sublime. Iron 3 chloride sublimes, and sodium chloride does not sublime. So the first thing to do is to heat the mixture so that whatever sublimes leaves, so that you remain with 2. So heating the mixture, iron 3 chloride will sublime, change to a vapor, and it's collected on the cooler parts of the evaporating dish or the cooler parts of the beaker. Then after that, now you have lead 2 oxide and sodium chloride. Sodium chloride is soluble in water. Lead 2 oxide is not soluble in water. So the next thing you will do, you will add water into the remaining mixture. You add water into that mixture and stir it so that the sodium chloride dissolves in the water. Then from that, you can now perform filtration. You filter so that the lead 2 oxide remains as a residue on the filter paper, while the sodium chloride passes through as a filtrate into the other container. Then from there, you can heat the filtrate, now which we are saying is the sodium chloride, to evaporation. You heat the filtrate, evaporate it to dryness to obtain sodium chloride. So heat the filtrate to dryness to obtain sodium chloride. Now with that, I would like you to just assess yourself whether you've understood the concept by attempting the following questions. The first one says, describe how aluminium chloride can be separated from a mixture of aluminium chloride and sodium chloride. So the hint there is, look for something or a substance that sublimes. Then, it's just that easy. Number 2. Name 3 physical properties considered when separating components of a mixture. I have mentioned 3 properties, physical properties, which enable us to tell what method of separation we are going to use for a given mixture. So, can go back to the notes and check which properties those are. Otherwise, that marks the end of our lesson and the 2 most common methods of separating solid mixtures. So we shall meet in the next lesson, whereby we shall look at liquid solid mixtures and their methods of separation. Thank you so much for your cooperation. Please keep following, keep subscribing, sharing, and let's keep learning.